In this lesson, we are going to find out points on the line joining two charges where electric field is equal to 0. In the first case, the charges are of same sign. So here we have a plus Q charge, and here we have a plus 3Q charge. So we've taken both the charges as positive. We could have taken both the charges as negative also. Now, if we consider a point here, this plus charge will create an electric field away from itself. To find the direction of electric field, imagine a positive test charge plus Q0, and then look at the direction of the force on that positive test charge. That will give us the direction of electric field. So this plus charge will create an electric field away from itself in this direction. Same way, this plus charge also will create an electric field away from itself. So that electric field also will be in the same direction. Therefore, there will be no point on this line except at infinity where electric field will be equal to 0. Same way, if we consider a point this side, this plus charge creates an electric field away from itself. This plus charge also creates an electric field away from itself, and therefore both the electric fields get added up, and there will be no point except infinity where electric field will be equal to 0. Now if we consider a point in between the charges, then this plus charge creates an electric field away from itself. This plus charge creates an electric field away from itself. Therefore, there will be some point where electric field will be equal to 0. The electric field due to this and the electric field due to this will be exactly equal and opposite, and they will cancel out. And since electric field falls over as 1 over r square, this point will be closer to the charge of smaller magnitude. So when the charges are of same sign, there is a point in between the charges closer to the charge of smaller magnitude where electric field will be equal to 0. The electric field due to this charge at this point will be given by that same formula, electric field due to a point charge. If this distance is x, then the electric field will be equal to K, which is Coulomb's constant, 1 by 4 pi epsilon naught, this charge Q divided by the distance squared. And if this distance is d minus x, total distance between the charges, let us call it d. So if this is d minus x, then the electric field due to this will be in opposite direction, and that will be given by K into the charge 3Q divided by d minus x whole square, the distance squared. And these two must add up to 0. Okay, we assume that d is the distance between the charges. For calculation, we can take d as 1 meter, say. Now, this implies that kq by x square will be equal to k into 3q by d minus x whole square. So kk will cancel, qq will cancel. And since there is a square everywhere, we can take square root. So we get 1 by x equal to root 3 by d minus x. So now if you cross multiply, d minus x becomes root 3x. So therefore, we can take this side, we'll get plus x. So x is common, root 3 plus 1. So x becomes d by root 3 plus 1. We can rationalize this, multiply numerator and denominator both by root 3 minus 1. This will give us 2, and d is 1, so we get root 3 minus 1 by 2. Root 3 is 1.732. Okay, we can take it as 1.74. Minus 1 will give us 0.74 by 2 is 0.37 meter. So the point where electric field is 0 is in between the two charges, closer to the charge of smaller magnitude, right?